Hi class, this is Sir Alex. Welcome to our lesson in General Physics 1. We're going to continue on with our discussion in lesson 4. It's still part of dynamics of translation. And last time we've talked about the three laws of motion by Sir Isaac Newton. And for this lesson, we'll be focusing a lot more on the second law of motion, which is the law of acceleration. We will use the second law of motion or second law in motion on various applications in real life situations and problems. This would be two parts. For this part one, we'll be dealing with two types of examples, and the rest will deal with part two. So let's begin our study on the applications of Newton's second law on motion. Okay. So the goal of our today's lesson would be for us to understand how to draw a free body diagram. Later, I will also explain what is free body diagram and how it is useful in solving problems related to Newton's second law on motion. Moreover, for us to understand how to apply the second law of motion or the law of acceleration and the equation accompanying the second law of motion, which is F is equals to ma, that we've discussed previously, and also how to go back to lesson 3, which is kinematics, and also apply kinematics to Newtonian problems. And so that would be the goal of our today's lesson. So let's begin. So the first thing that I want you guys to learn is how to use a free body diagram. So free body diagram is very important when we are trying to solve Newtonian laws motion or problems relating to Newton's law on motion. That is because it simplifies things for us. It creates a visual representation of what is happening in the problem. So a tip that I want you guys to remember is when you have problems regarding dynamics of translation, or in this case, Newtonian problems, it is best to draw things and use free body diagram. Later, I will show you how to do that. But let's understand first more what is free body diagram. It's basically a diagram of forces that is acting on a body isolated from the rest of the system. So let's identify what do we mean by isolated from the rest of the system. The Newtonian's law of motion can actually be applied to individual parts of the system. So when we talk about the whole system, we are looking entirely at what is happening in the motion. And then we can actually take it apart. And the second problem that we'll be solving today, you will see on how we can actually do that. But again, I want you guys to remember that it is possible to isolate individual parts of the system, and then try to measure each forces acting on those individual parts. And then by doing that, we can actually solve for whatever we want to look for example, acceleration of the whole system. We can solve that by uh, breaking things apart or breaking the system apart and identifying the individual forces acting on each important parts of the system. Um, Probably doesn't make sense now, but later I will show you what I mean. So just I want you guys to remember when we talk about the entire system, when we are dealing with the entire system, the mass, force, and the acceleration that is happening in the entire system. When we talk about mass, we are talking about the total mass available in the system. And when we talk about force, we are talking about the net force acting on the entire system. The same thing when we talk about the acceleration, it is the acceleration all throughout the system. When we talk about part of the system, so meaning this is the whole, and then if we take things apart, we take things individually. We look at the entire system and take individual parts of that system. When we now deal with part of a system or individual isolated parts of the system, we are dealing, when we talk about mass, we are only talking about the mass of that isolated part. The same way, when we talk about force, we are only talking about the force that is acting on that isolated part, not the entire system. The same way, when we talk about acceleration, the acceleration that is happening on that part of the system, not the entire system. For now, like I said, it may not be clear what is happening, but um, later, especially on sample problem number one or number two, you will see what I mean by that. But having said that, another thing that I want you guys to remember is the direction of the motion may be considered the positive direction. What do we mean by that? Last time when we talk about kinematics of translation, we talk about a coordinate system, remember? And in that coordinate system, we usually use the positive and the negative y. So we use this in kinematics. So when we talk about east, we are talking about positive. When we talk about north, we are talking about positive. But when we are dealing with west, we are talking about negative. And when we are dealing with south, we talk about negative. But for dynamics of translation, you can actually edit this out. It's up to you. You can follow this or you can follow the direction of the motion. So you can use the direction of the motion as the positive direction. So halimbawa, madalas na ginagawa natin when things move towards the east, especially in kinematics of translation, we usually talk about it going in the positive direction. And when we talk about things in kinematics that is moving west, madalas na ginagawa natin siya negative, tama? But for dynamics and translation, it's up to you. If, for example, the car is moving towards the west, you can set that up as your positive direction. It doesn't matter. You just have to remain consistent with the use. So if you use your west as your positive, then things that are moving towards east would be negative. So halimbawa, you have things that is going downward, you can use that downward position as positive. So that's one thing that I want you guys to remember. Okay, that the direction of the motion can be the positive direction. You do not need to follow yung configuration na nasanay tayo, which is north is positive, east is positive, west is negative, south is negative. You don't have to follow that. You can if you want to, but it's up to you. The same thing that I want you guys to remember is with G. Nasanay tayo na yung G natin is always negative 9.8, especially when we are talking about projectile motion and free fall. But for kinematics of translation, G can be positive or negative. And this is because it is depending on the motion that you've chosen. Depende siya sa configuration na ginamit mo. So kung pag ang ginamit mo, ang movement is going down, then you can use G as the positive direction. Or yung G mo, magiging siyang positive. So it's up to you. I hope that is clear. So let's try this sample problem. Sample problem 4.2.1. So this is still quite easy. Let's use the whiteboard because we're gonna need it. We're gonna need some space. Okay. Let's just wait for this to load. Okay. So let's read the problem. So a 10-kilogram object resting on a horizontal frictionless surface is subjected to two forces. So we have force 1, which is 30 newtons, directed to east. And then we have force number 2, 15 newtons, that is directed west. Ang hinahanap natin is find the acceleration and the displacement after starting from rest, or 10 seconds after starting from rest. So let's first write our given. So para hindi tayo malito, let's still use our GAFS format. Okay, So let's write the given in our problem. So according to our problem, we have an object that has a mass of 10 kilogram. And this 10 kilogram is moving on a horizontal surface that is frictionless. And it is subjected by to two forces, which is force 1. And force 1 is equal to 30 newtons. And this force 1 is directed towards east. And we have force number 2. We're gonna use F2. And F2 is equals to 15 newtons, and it is directed west. Then what they're asking us, ang hinahanap sa atin ng problem is, let's just write, okay, is first, what is the acceleration of the object? Acceleration. And B, what is the displacement? So dito na pumapasok yung kinematics of translation na binanggit ko kanina sa goal natin. So do not forget the kinematics of translation, especially the equations, kasi gagamitin niyo pa rin sila sa mga problems sa lesson 4 or the dynamics of translation. Okay, so formula. For formula, so you can see this is we are dealing with Newtonian motion, especially the second law of motion. Ang formula na gagamitin natin madalas is F is equals to ma. That's why I want you guys to remember F is equals to ma, because you'll be using this almost always, especially in lesson 4. Okay, so now let's talk about, or before that, now we have our given, we have our ask, and we have our formula. So usually yung gagawin natin is we're gonna head to solution. So in order for us to solve this properly, let's first create a free body diagram. So if you guys remember, pag-usapan natin kanina, ano ba yung free body diagram? This is a diagram that shows all the forces that is acting on an object. So halimbawa dito, yung object mo, this could be a car, this could be an animal or whatever, cart, a rock, or a box. It doesn't matter. That's why we use the word free. It's up to you. You can represent your object however you want. In this case, siguro mas madali ang gagamitin natin. Usually, you can use like a dot. You can use that. Dot represents your object. Or you can also use, for example, a rectangle. So in this case, let me use a rectangle. Let me draw it here. So this is my object. So this object represents the object in the problem. And alam natin that this object has a mass of 10 kilogram. And this object is subjected into two forces. One that is going east. So ang gagawin natin to represent that, you can use an arrow to represent your force. So we have our F1, which is equals to 13 newtons, and it is going in the east direction. So this is our east direction. Next, we have our second force. And it is kung papasin nyo, the arrow is quite longer because let's just erase that. Let me draw a longer arrow because the force towards the east, our F2 is bigger than our F1. So we have our 15 newtons and it is directed west. That's why the arrow is going west. Okay, so this could be your free body diagram. So this is a representation of what is happening. Another thing that I want you guys to remember is surfaces. Okay, So when we are dealing with surfaces, usually meron tayong tinatawag na Fn. This Fn is what we call a normal force. Normal force is a force that is being acted upon on a surface. So halimbawa dito, alam natin na nakapatong siya sa isang horizontal surface. And that horizontal surface is actually uh, tawag dito is giving a force that is parallel to the surface. So this is our surface, this dotted line here. So it is sitting on a surface, and this surface gives a force that is parallel to the surface. And I think ang tawag natin dito is normal force. The reason for this is because everything in the world actually creates what we call a weight. And remember, weight is a force in kinematics of dynamics of translation. And this weight is usually equal to mg, the mass of the object, multiplied by g. So if we draw a free diagram, these are actually all the forces that is acting on our object. So papasin nyo, hindi naman niya sinabi yung weight, hindi naman niya sinabi yung normal force. But these are some of the assumptions that I want you guys to immediately always remember. Everything on the earth is always being subjected by the force weight, and this weight is always equal to the mass of the object multiplied by gravity. Again, remember then, pag-usapan natin kanina, this g can be positive or negative depending on your configuration na pinili ninyo. So kung yung movement niya is pababa, you can use positive sa g. And then we also have a force, normal force, that is acting on the surface. So anything that you have a surface, you have to create a normal force that is perpendicular to the surface. So we have force N. And this force N, normal force, is actually equal to our weight. The reason for that, because hindi gumagalaw sa y direction yung ating object. If our object is moving in the y direction, either going up or going down, it means the weight can be pulling it down or something is pushing it up. Okay? Pero since yung object natin back dito, from the problem itself, it's actually not moving. So Fn is equals to weight. Okay? So if Fn is equals to weight, the forces that is pushing it up is equal to the forces pushing it down, then it will not move it will not move up and it will not move down. But what will happen to this object, it actually will move in the horizontal direction. And we know that because there is an unbalanced force. Our force directed towards west is higher than our force directed towards east. So since the force towards east is higher, we know that this object will have to move towards west. So since that is the direction of our motion, we can choose this as our positive. Okay, now let's solve for the acceleration of this object. How can we solve for the acceleration of object? Remember our formula. F is a net force, so meaning all the combination of all the forces acting on the object. And this is equals to the mass of the object multiplied by the acceleration of the object. And since we are looking for the acceleration, let me write that. So we are looking for acceleration, and we use the equation F is equals to ma. We can rearrange this equation to A is equals to F divided by the mass of the object. So now we can solve for the acceleration. Okay. So the acceleration is equals to the net force. So the net force that we have, we're only going to consider our force 1 and our force 2. We can remove our normal force and our weight because it's not moving in the y direction. It is not going up, it is not going down. If it is going up and going down, then we have to add this in our force. But since it's not going up or down, it's only going on the horizontal. Um, it's only going in the horizontal direction, more specifically towards west. Then ang mga forces lang na i-consider natin are the forces acting on the horizontal direction. So all the forces acting the horizontal direction is F1 and F2. And we chose F2 as our positive because it's directed towards F2. Therefore, this F1 is in the negative direction. So the sum of all our forces is actually equal to positive 50 plus negative 30. So that would give us 50 newtons minus, or let's just say plus para hindi kayo malito, negative 30 newtons divided by the mass of our object, which is equal to 30 kilogram. So now you can plug in your number. 50 minus 30 is equals to 20 newtons divided by 10 kilogram. Remember the units for Newton. 1 Newton is equals to 1 kilogram multiplied by meters per second squared. Since we are dividing it, we cancel the kilogram and we are left with meters per second squared, which is the unit for acceleration. So therefore, our acceleration or the acceleration of the object is equals to 2 meters per second squared. And it is directed toward west. So that would be our answer for letter A. Okay, I hope that is clear. Okay, now let's move on to letter B. Okay, so for letter B, we are looking for displacement. So when we're looking for displacement, this time we are considering na yung kinematics. Okay, so the kinematics, if you guys remember some equations for displacement, includes, for example, um, d is equals to initial velocity multiplied by time plus 1/2 v squared. Yeah, I believe 1/2 v no, acceleration 1/2 at squared. Another equation that you can use is 2ad is equals to final velocity squared minus the initial velocity squared. Okay, so you can choose any of these equations to solve for displacement. However, you have to consider what were you given. So you were able to find the acceleration. Therefore, you can use the acceleration to find the displacement. And the only thing, the equation, only equation that has an acceleration is this part. So we're not gonna use, or both has, sorry, merong acceleration doon. Pero another thing that were given to you, or what you're looking for, displacement, another thing na ibinigay sa inyo is actually this word, from rest. If you guys remember, from rest, that's VO is equals to 0 meters per second. So now you can either use this velocity, so you can remove that and you can remove that, and then you can either use any of these to find the displacement. Pero may issue pa din kasi wala kayong final velocity. So in the end, you cannot use you were given time, sorry. Medyo nalito na ako. So another thing is you were given time. So that's 10 seconds. So that is time. And unfortunately for the second part, you do not have time. So we cannot use that. We have to use the first equation. So that's dx, or basically displacement is equals to v initial t plus 1 half at squared. Again, our initial velocity is 0, so that's 0. We are left with t is equals to 1 half at squared. So just plugging in your numbers, 1 half multiplied by 2 meters per second squared, and the time that you're given is 10 seconds squared. And your displacement is equal to, just check, that's 100 meters. And that's 100 meters towards west. So that is your answer for letter B. Okay, so since this is 25 minutes already and the second part will take a little longer time, I'm gonna end this and make this our part one for part one of our lesson 4.2, and then there would be the second part of the video for the second problem. So that will be the end for this problem. For the next problem, please watch the next video.